As we seen the previous demonstration was completed in a few seconds. That's why we are trying to demonstrate our project manually. The project is so on. As we are, it's initially moving with a slow speed, as it's having no signal. After that, it's crossing the signal, which having green data. Then it moves with a fast speed, and then reaches the next station, and it gets the yellow data, and it moves with a slow speed. After moving for next signal, and when it gets the data red, it stops manually. Here is in our project. Actually, we are here in our project. Actually, we are trying to control the signals through decoders and using a algo in our microcontroller program, so that we can easily control the signals automatic. And after that, as we can see here is a RFID identification. Okay, actually it is used for identifying radio frequency. We have mounted a RFID. We have mounted a RFID card on the train. As it moves from there, it shows the name of the train, as you can see here. As we have entitled our project name as a novel signal system for better railway network management. It is because we have used here three technologies to communicate with the train. First one is a IR. We can see here. This is the IR transmitter. IR stands for infrared transmission. We are used here IR for the transmission because in case of fog or bad weather, the train had to suffer a lot along with the passenger. We had to lose the most precious timings. So that we have to reduce these problems, we have tried that we can give the signals to the train cabin, so that driver can easily get the data, whether it is visible or not, and so that can regulate the train's speed. So here is the infrared transmitter. After that, it is getting the data and it is displaying in the train's cabin. After that, we have used second mode of communication is radio frequency. You can see here radio frequency transmitter. We have given the station master the capabilities to regulate the trains to regulate the timing or the speed of the train. Here are the four channels which we have used. First one for a stop. A station master can give the data to a stop. Second one for slow down. A station master can give the data for slow down. Third one is normal. Fourth one is the fastest. In case of fastest, the train will move the fast data. We have enabled this capability only because in case the trains doesn't know how many trains are behind it. So in case if there is a more congestion in train routes, so that the station master can regulate the trains, regulate the speed of trains, and can do better and minimize or can utilize the full capacity of our train. After that, here is the transmitter receiver. RF receiver gets the data. Okay. After that, the third mode of communication is GSM. We are also giving the ability to the responsible person or the railway authority, so that it can regulate the train speed either in case of any problem or any want. In case of any problem, it can give this data to send to give the data to the train to stop or to move or to slow down or to fast. Okay, these all data are collecting here to the peripherals inputs. After that, these data are sent to the ICs. IC is getting the data. After that, through serial communication, it is giving that data to LabVIEW. After processing through the LabVIEW, it is giving back the data, and this all are given back to the peripherals, and the signals or the management is taking its work according to the program.
Here we have LabVIEW interface with our project. In this LabVIEW interface, we have one LED which is showing, which is glowing when data is not received. and other bits are the data in string form, in converted number form, and finally all the bits from RF module, from GSM data and from IR sensor data is converting in a Boolean array, because we are sending 8-bit data. So we are converting all the data in Boolean array, and it is a read-write cycle. The delay between reading and writing among all the cycles. After getting this Boolean array received and all the 8 bits, we are separating all the bits by using some logics in LabVIEW block diagram, and we are separating all the data from here. IR sensor data, here you can see the red is glowing, and other data is yellow, green, and no signal. There is separate data. For RF module data, we have stop, slow, normal, fast mode, and GSM data we have stop, slow, normal, fast mode. And based on these data and based on algorithm designed in LabVIEW block diagram using C program, we have a final conclusion to stop the train, to slow down the train, to get a normal speed of train, or we can speed up the train. So as you can see here, when the data is red, the IR sensor is giving red data. It means our signal is red. Then if we changing any other data, that even we are getting a fast speed here and fast speed here also, or a normal speed or any other speed, normal speed also here, then also the final decision is stop the train. Now if we are getting yellow signal, then you can see even we have a fast speed here from RF module, then also the speed of the final conclusion, the speed of the train is normal, because we have a yellow signal here. In yellow signal we don't allow train to get a highest speed, even either normal speed, either slow speed. In green signal, when we are getting green signal from IR data and getting any data from RF module like normal speed, if it is giving normal speed, then also we are getting normal speed. If it is giving fast speed, it is giving fast speed to the train. And it can be automatic. If we are switching off, then it is a manual mode, and we have to the train operator has to decide has to operate the train by getting this data visually. And if we have this automatic mode on, then in that case we have the train operator don't have to operate train manually. All the data is writing back by the LabVIEW using RS232 serial communication. And here you can say we lost the data within the conversation. So in that case we have LED data is not received, and when we are getting the data, it will change the data and the speed of the train also. In automatic mode, it will direct the train speed to it will give the data to the train transmitter, and according to the based on the decision, we can have automated regulated speed of the train without a train operator also in this automatic mode. In this LabVIEW block diagram, we have a visa configuration of serial port where we are configuring this visa for reading COM1 port at 9600 baud rate. After communication established, we have visa write and visa read. First of all, visa read. In this visa read, we are getting output as a string, and we are converting that string by using this logic into a Boolean array. of 8 bit, because we are sending 3 bits, 3 information multiplexed within the 8 bits. The first 4 bits responsible for IR data, next 2 bits, 5th and 6th, responsible for RF module data, and last 2 bits are responsible for GSM data. So after receiving this 8-bit Boolean array, we are separating all the bits by using this logic, and here we can see the first 4 bits are IR sensor data, second, 5th and 6th bits are that RF module data, which is converted here by this logic, and last 2 bits are GSM data, which is converted here by using this logic. And we are showing these LEDs in the front panel also. You can see here, this front panel we are showing these LEDs. Now after receiving the data, we have to make a decision. So for making a decision, we made C programs here to convert these logic to the final decision. After making the C program, we have some block diagrams here, and after this program, we have final decision to stop the train, to slow down the train to normal for normal speed, or to speed up the train. These final outputs are shown in this block diagram here, in this front panel here. And now after receiving the data, for writing back the program, we have another C program here, and after receiving this final result into a variable x, we are converting this x into a string, and we are writing back this string into this write mode. And also we are showing the speed of train for a visual perception into another variable, that is speed, and this visual perception is shown here in this form, and when speed is changing, it is also changing.